This week we're starting to transition some from probability into statistics. And we want to look at how would we talk about real-world studies and how would we interpret the information. So, research studies are one of science's best tools for learning about the world around us. But scientists are human and sometimes make mistakes. Sometimes they don't know enough about a situation to determine what's really going on. Or sometimes other people misinterpret or deceptively portray scientific results to advance their own agenda. When deciding how much to trust a research study, you want to ask yourself these questions. Who produced the study? Was it someone with a vested interest in the outcome? Was it a professional research firm or university? Where did they get their funding from? Is it from a related industry or neutral party? All these could impact the findings, or not necessarily the findings, but the way they're interpreted. What are the population and sample? So the population is the entire population that's being studied, and the sample is the small group that you may actually do the study on. Because you couldn't, let's say we're trying to find out how many pets, what's the average number of pets that Americans own. You're not going to interview every single American. So Americans would be the population. The sample would be the ones that you actually interviewed. Does the sampling method seem likely to provide a representative sample? So let's say same situation, but we only interviewed women, okay? Would only making our sample women represent all Americans if our population is all Americans? No. Do the conclusions fit with the population that was studied? Are the survey questions worded fairly? If people were surveyed in this study, were the setting and phrasing neutral? Could the question wording have encouraged people to choose one option over another? Are the variables clearly defined? So the variables are the things that we're measuring. Were the variables easy to objectively measure? If not, how were they defined for the study? Does this definition make sense, and was it applied equally across the study? Could hidden variables be affecting the results? Could there be variables that they're not considering that could be affecting the results? All the relevant variables, are they all accounted for in the study? Could there be something that nobody thought of that's affecting the study? Do the conclusions make sense? Do the conclusions follow from the study results? Did they actually conclude something that they were studying? Or was it something slightly different? Just so they could say what they wanted to say, Do they make sense in all situations? Or would they only be relevant sometimes? And last, is someone being tricky with graphs? Do graphs show the results fairly? Is there anything odd going on that could make the graph misleading at first glance? So let's look at a few examples here. It says, to test the lung capacity of women, students at NCSU recruited 100 women on campus to participate in a study. 50 of the women were smokers, while the other 50 were non-smokers. The lung capacity of the women was tested by having each woman blow into a spirometer. Identify each of the following. Who produced the study? Well, that would be the students at NCSU. What's the population? Women. And the sample then would be the 100 women on this campus. Do we think that's representative of all women? Okay, because that's our population. It doesn't say anything about just women on this campus. It says women. So is that representative of all women? Not necessarily. I don't know how to spell that word. Because these women on campus are likely, 18 to 24, maybe, something like that. So it's not necessarily representing all women. The variables of interest. So the variable of interest here is the lung capacity. And is it clearly defined? Well, yeah, I guess so. It's being tested by blowing into the spirometer, so assuming that is an accurate test of lung capacity. Not positive myself, but if it is, then, it is clearly defined. Can you think of any hidden variables that could affect the results? So we're comparing smokers to non-smokers here. So what hidden variables could there be? What if there's an underlying lung disease in some of these women? Okay, that would affect their lung capacity other than just smoking. And there could definitely be other things there, too. Example 2 says, a total of 4,486 widowers of 55 years of age and older were followed for 9 years since the death of their wives in 1957. Of these, 213 died during the first 6 months of bereavement, 6 months after their wives died. 40%, that is 40% above the expected rate for married men of the same age. So they're saying more men were dying after their wives died at a younger age than if they were still married with their wives alive. The study concluded that the widowers have a higher death rate than married men of all ages. Referencing the guidelines for the section, explain why you should or should not believe the conclusion of the statistical study. Well, it's hard to say. I think it's pretty believable. I'd say unless there is a hidden variable that I can't think of. We'll say the study should be believable, but I'm really not, really positive. It seems good to me. Everything seems very defined. And what their conclusion matched what they were studying. So I think that this is a believable study. If you disagree, let me know, because it'd be helpful. Okay, and then example 3, let's look at misleading graphs. These are easier to talk about. So this graph shows the amount spent by the USDA on conferences in 2008 to 2012. Why might the graph be misleading? It says the U.S. Department of Agricultural conference costs between 2008 and 2012. And they're using pictures of corn for our graph here. And so they're saying in 2010, the most amount was spent, and they're showing that, the most amount was spent by having a bigger piece of corn. And each amount, let's see, in 2009, the corn gets a little smaller. In 2011, a little smaller. And the smaller was 2008. No, actually 2012. So, it tells us what we need to know, but could it be misleading? Well, in 2010, the amount they spent on these conferences was $17.6 million. In 2009, they spent $14.2 million. Now look at the sizes of these corn. This one, I'd say, is more than twice the size of that one, right? But is the amount spent, $17.6 million, more than twice the amount spent in 2009, $14.2 million? No, not at all. So it's misleading because it's making us think that they spent this huge amount more in 2010, while, yes, it was more, but it wasn't that much more. And then we can look at the other ones, for 2012, we're talking they spent about a third of what they did in 2010. And this corn is much smaller than the one in 2010, much more than a third smaller. So the sizes of the corn are throwing things off here. And so I'm just going to say, for one example, the size of the 17.6 million corn is twice the size of the $14.2 million corn. While 17.6 million is not twice 14.2 million. And all the corn sizes here are more misleading. Okay? You'll have a few of these to practice.